This is our last section of notes for the year. 8.3 is on titrations, which is a lab procedure that's used to find the concentration of an unknown acid or base. You will be doing titrations virtually in the lab, the virtual lab, tomorrow. Titrations are done in order to find the concentration of an unknown acid or base using a standard solution. The standard solution is the solution of known concentration. So in a titration, you react an acid plus a base, and you have to know the concentration of one of them, and using the concentration and volume, you can find the concentration of the unknown solution, which is called the analyte. The analyte is the solution that of the concentration that you don't know. You're going to titrate to something called an endpoint. And so in 8.1, we were looking at properties of acids and bases, and in the last virtual lab, you used an indicator, and we saw that the indicator changed color with acids and bases, or was a different color with acids and bases. So we're going to use an indicator in the titration, which will change a color at the point of neutralization. So you have an acid plus a base, those are going to neutralize each other, and at that point of neutralization, it will reach the end point. So let's go through the process. In a titration, you're going to start with a measured amount of acid in a flask. So typically, you start with the acid in the flask, and you know exactly how much you start with. And then you put a base in something called a burette. A burette is a graduated glass tube with a tap at one end for delivering known volumes of a liquid, especially in titrations. Thank you, Google. That's the Google definition. It looks like that picture. Thank you, Google Images. You can see, and if you were to look at it closely, it would look like a graduated cylinder, except that when you look at it closely, the 0 is up here, and it measures going down. So you use this nozzle down here at the bottom to dispense the liquid. And you measure up here, measuring down. Now, there's a special way to read the burette, and you're going to read a burette from the bottom of what's called the meniscus. The meniscus is kind of that surface of the water. And it's going to have a concave meniscus, and you're always going to read from the bottom. Also notice that this is going to measure by tenths of a milliliter. Like 21 is up here, and then 21.1, 21.2, 21.3, which would be the measurement on this burette. You're always going to measure going down. So when you have a graduated cylinder, you'd measure going up, but that's because 0 would be down here at the bottom. So we're going to measure kind of in the opposite way that you would measure with a graduated cylinder. The burette then is used to dispense that base into the flask. So you're going to have your acid in a flask, you have the base in a burette, you add indicator to the acid. We're going to use phenolphthalein. Phenolphthalein is how you say that indicator. If you remember from the virtual lab, phenolphthalein is clear in an acid, and then you're going to add the base from the burette to the acid, and when it reaches its neutralization point, or just past neutralization, then it's just basic, it's going to turn pink. And that point is called the end point. Remember, phenolphthalein is clear in an acid and pink in a base. And so when you start, you're going to have your acid with the phenolphthalein. It's going to be completely clear in this flask. When it reaches the end point, it's going to turn kind of light pink. If it turns this dark pink, that means you've gone too far. And we'll see an example of each of those when you do the virtual titration lab. The last step then is from the amount and concentration of the standard solution, you can calculate the concentration of the analyte. You're going to do that using this equation, which looks more complicated than it is. It's going to include the number of hydrogen ions from the acid. MA stands for the molarity of the acid. VA, the volume of the acid. That is equal to the number of hydroxide ions in the base, the molarity of the base, and the volume of the base. This is actually like doing stoichiometry, but all in one step. So we've kind of simplified it. Instead of having to do stoichiometry, you've got your molarity and volume that will give you the moles. That by multiplying by the hydrogen and hydroxide, that takes care of your mole ratio, and then we're converting back to molarity and volume, this time of the base. So let's do a couple of examples. Here we have a 25 milliliter solution of H2SO4. It's neutralized by 18 milliliters of 1 molar NaOH. Using phenolphthalein, what's the concentration? What's the molarity? Now, this one is different than in 8.2 when we were solving for the concentration of H2SO4 just by using the moles per volume, because it's a reaction. You have an acid plus a base reaction. Neutralized is going to be kind of a key word here. Also, the fact that it tells you it's using indicator is going to help you know that this is a titration question. We want to take into consideration the number of hydrogen ions in the acid. So when you look at H2SO4, there are 2 of those. The next variable is the molarity of the acid. That's what we don't know, because the question is, what is the concentration of that acid? Then we have times VA. We need to consider the volume of acid. The volume of the acid was 25 milliliters. It's okay to use milliliters in this equation, because as long as you have milliliters on both sides. On the other side of the equation, we have the number of hydroxides. In NaOH, there's just 1. The molarity of the base is also 1 molar. And the volume of the base is 18 milliliters here. So we have, as long as you have milliliters and milliliters, you can keep that in milliliters. You don't need to convert it to liters like we did in the last video. In this case, then you want to multiply 18 times 1 times 1 and divide by the side with the variable, and that will give us the molarity of the acid, which is 0.36 molar H2SO4. In the second example, it says 50 milliliters of 0.1 molar NaOH is neutralized. There we have that word neutralized again. So we can see we have that acid-base reaction. This time we're going to find the molarity of the HCl. HCl only has 1 hydrogen in it. We don't know its molarity, and the volume is 5 milliliters. On the other side of the equation, all of this goes together for the base. There's 1 hydroxide. The concentration is 0.1, and the volume is 50. And so this time we're going to take 50 times 0.1 times 0.1, which is 5, and divide by 5, and we get a molarity of 1. This would be 1 molar HCl. You're going to put that into practice by doing practice 8.3, and then we'll get to see this a little bit more visually, a little bit as much hands-on as we can in this situation by doing the virtual lab tomorrow.